All right, we're on Unit 2, Day 8 today. This is the last day of learning something new for this unit. If you take a look at your assignment sheet, we're going to be talking about functions a little bit more, so expanding on what we did yesterday and combining a day from earlier on in this unit where we did evaluating. That was where we substituted a number in and then simplified it. So if we go to our Unit 2, Day 8 notes page and scroll down to where our notes start, we're going to talk about evaluating a function or writing something in the f of x way of writing or in function notation, I say, is f of x. So if we take a look at this part, forgot to do edit. Zoom. All right. So if we take a look at this right here, right, this f of x, I just want to make sure that we understand that it's basically the same thing as writing y equals in the front of an equation. So this is something we're used to seeing, y equals 2x plus 5. It can also be written as or f of x equals 2x plus 5. And let's talk about what this is stating here. So this is considered on the right side function notation. On the left side is something you're probably used to from last year when we were graphing, where it just said y equals. Just know that y and f of x are interchangeable when we're talking about graphing, but the one on the right side gives you a little more information. It will actually be able to give you what number you plug in for x and what number we're going to get out. So if we were to take a look at the steps for evaluating a function, we know that evaluating a function from a few days ago means that you substitute a number into the equation and then you simplify it. So we're going to do that today a bunch of times, and it's going to be the same idea that we did a few days ago, but now in our final answer, it's just going to be written a little bit differently. It's going to be written in what's called function notation. So the first thing we have to do to evaluate something or to evaluate a function written in f of x notation is the first thing that we did a few days ago, and that's just substitute a number. So substitute. Substitute a number. In for a variable. In this case, I think it's always for x. So substitute a number in for x. So that's our first step. Then our next step is the same step that we did before. This is where we're going to simplify the expression, or just finish it. So we're going to substitute it in, and then we're going to actually try to get it down to a single number. And then my last step, this is where it's just different from before. We're going to write the answer in this function notation. So write the answer as f, let's do lowercase actually, that's what it's usually written as, f of the number that you plugged in equals your answer, whatever you get out. So that's how we want you to write the answer in the end. So let's do an example here up above. So when we are on the left side, it's saying to evaluate when x is equal to -1, and the equation is y equals -3x plus 6. So we learned a couple days ago that we just plug in -1 for x, and then we simplify. So this is y equals a negative times a negative is a positive 3, and 3 plus 6 is 9. So that's my final answer, y equals 9. The right side here is almost the identical equation to start, but it's written in function notation, and it's telling you to find f of -1. So the thing about function notation is it gets rid of all this wordage here and makes it a lot more succinct. So that's why people will use function notation, because you don't have to write a sentence, the evaluate when x equals. You can just write find f of -1, and that's just stating plug in -1 for x, because there's always an x that starts off right there. So now we're replacing the x in the equation. So we're going to replace this x right there with this -1. So as we do that, it's going to be f of -1 equals the same thing that we just did on the left side. So we said that a negative times a negative is a positive 3. And 3 plus 6 is 9. So if we compare these two answers, this one that we started with and this one that we did on the right side, the one on the left is not in function notation, the one on the right is. And we know that because of the f, which stands for function. It's got a parentheses, and it tells you in that parentheses what we plugged in. So it's telling you we plugged in -1, and if you plug in -1, you get what's on the right side here, which is 9. On the left side, though, it did not tell you all that information. You'd have to go back to the original question and see what you plugged in order to get 9. On the right side, though, it told you within your final answer, it said in the function you plugged in -1 and you got 9. So people like writing or dealing with function notation because it tells you what your question is in the final answer. So it tells you you plugged in this number and you got this number out. So let's do a few more of those because they get a little more tricky as we go through. So on page 2, oops, didn't mean to make that thing. All right, so let's go down, down. All right, so up top, it says use these functions. So we have g of x is 3x minus 7, h of x is 2x squared plus 8, and f of x is the absolute value. Those are those straight bars of x. So it says find the value of each function below. So this g function, for number 1, we're going to use this equation right here. So that's what we're going to use for the first one. So g of 2 equals, we already know we're plugging in 2 for x, so that'd be 3 times the 2, and then minus 7. I ignore the h of x equation, the f of x, because this started with a g, so I'm only going to use the g equation here, the g function. So that would be 3 times 2 is 6. 6 minus 7 is -1, and that's our final answer. It's in function notation. It tells you what number you plugged in, which was 2, and what number we got out in the final answer, which was -1. If we do this number 2, it starts with an f, so that means we're going to use this one. So f of -2.5 would be the absolute value of -2.5. This is where I'd use my calculator, my graphing calculator. So we go to math. Let me open it up. So we go to math on the left side, that was under alpha. We arrow over to the right one under NUM and select abs. And then we plug in -2, which you get the negative button next to period. So -2.5. I'm going to close the abs or get out of it if you're in an 84 and press enter. You get positive 2.5. So now f of -2.5 is equal to positive 2.5. So that's our answer for number 2. So those two are easy so far. Let's do the h one. That means we're going to use this one right here because it starts with an h right there. So if we plug in -4, that'd be 2 times -4 squared plus 8. So according to my order of operations, or if you plug that in your graphing calculator, you'd have to do -4 times -4 first because you're supposed to do exponents. So that'd be 2 times 16 plus 8. According to my order of operations, I do my multiplication before my addition. And then in the end, I get 40. So my final answer, if I write it correctly, would be h of -4. So that's stating what number you plugged in for x. You plugged in -4. And we got out the number 40 as our final answer when we simplified and evaluated it. So that's our answer for number 3. So that's plugging in numbers. So now we're going to start plugging in some variables. That's where it gets a little bit tougher. So I feel like that first half of your homework is not too bad, or the first part of your homework is not too bad, because you're just plugging in numbers and seeing what you get out. This next part gets a little trickier, and then the last part's the hardest part, so we kind of ramp it up. So this g function, so we know that g of x, I'm going to write it above so I can scroll or focus in a little bit stronger here. We know that g of x from above is 3x minus 7 in the original. So this is stating not to replace it with a number, it's saying to replace it with a letter. So that means every time we see an x, we're not going to replace it with a number, we're going to replace it with the letter a, according to that. And then we try to simplify. Well, we can take away the parentheses, and there's nothing else to simplify because those are not like terms. So my g of a, its final answer, is just 3a minus 7. There's nothing that we can do to it beyond that. So that's just asking you to replace the x with the letter a, and then we're done. Number 5 is the g function as well. So I'm going to rewrite that. Up above, g of x equals 3x minus 7. So that means we're going to replace this x with this 3b. So I'm going to also take this 3b and plug it in right there. So that'd be 3 times 3b minus 7. And when I multiply the 3 times 3b, that gives me 9b minus 7. And there's nothing more that I can do because these are not like terms, so I can't subtract them. One has a variable, one doesn't. So that would be my final answer, is 9b minus 7. So that's number 5. And then number 6 is even the toughest one. So I know the original, because we've just done it a few times, is 3x minus 7. So now it's asking us to replace this x with this whole thing here, with this 7c minus 1. So I'm going to write a 3, and then in parentheses instead of the x, I'm replacing it with 7c minus 1. And I still have a minus 7 on the outside to finish the problem. So let's see what we get if we distribute that 3 in. So that'd be 21c minus 3 minus 7. So in the end, g of 7c minus 1 is equal to, that's 21c, and then I can actually combine those two last terms, the negative 3 minus 7, and if you punch it in your calculator, you get negative 10 in the end. So 21c minus 10 is your final answer. So that's the tough one, I think, every year. And then 7, same g of x. So we haven't wandered off from that, at least. That's good. Makes it simpler because we know what that equation is. So we're replacing x with this 5p plus 3. So instead of writing 3x, we write 3 times 5p plus 3. And then minus 7. We multiply it. We get 15p plus 9 minus 7. So in the end, we would get g of 5p plus 3 equals 15p. 9 minus 7 is 2, positive 2. So that's my answer right there. So that's number 7. And the last one, it says find the value of 3 different pieces. So we're going to do all 3 separate and then actually subtract and add them together. So I'm going to write down what g is. We know that one. That's the 3x minus 7. So let's do the g of negative 3 part. So that'd be 3 times negative 3 minus 7. So g of negative 3 is negative 9 minus 7. G of negative 3 is negative 16. So that's 1/3. So this is negative 16 when we think of g of negative 3 now, we can say, okay, that would equal negative 16. And then f of 7, so f of x, if we look above, was the absolute value one. So f of 7 is the absolute value of 7. If we punch that in my calculator, I think in the end we get a positive 7 out. So that'd be minus 7 right there. And then h is the one with the squared, I think, up above. So that was 2x squared plus 8. So this is saying plug in 0 for x. So that'd be 2 times 0 squared plus 8. So that would be 0 squared is 0. 2 times 0 plus 8 would be 0 plus 8. So that should be 8 in the end. So now we have to figure out, when we replace these three pieces up above here with the numbers, that was negative 16, that was 7, that was 8. And there was a minus sign between the first two and a plus sign between the second two. So we'll punch that in our calculator, do order of operations, and in the end, negative 16 minus 7 is negative 23. Negative 23 plus 8 is negative 15. Negative 23 plus 8, yeah, is negative 15 in the end. So that'd be my answer if we did them all. Then the last page is some graphing. This is something that kids like usually for the function notation. It's probably been a little bit since you had to graph it all. So it's asking you to find what value the y is if they give you x. So this is all giving you the g of x to begin. And we know that for ordered pairs, they're always written in x comma y. And the x motion is left to right from the center, left to right. And y is up or down from the center. So how much did it move? So let's just plot some points here. So this point right here would be at, if we do the x first, that's negative 4. And we do the y, that would be 3, right? If we do the next one, this x, where the x is from the center, would be, it went 3 to the left. So that'd be negative 3, comma, and then it went 2 up. So it'd be negative 3, 2. So that's how we do ordered pairs. So let's see what they're asking us for. They're stating that if we plug in 0, okay, for my x, so that means we don't go left to right at all. We go 0. So that would be this point right here. This dot did not go left or right. What's my y at that dot that I just created down below the 0, 0 point, or the origin they call it? So we always start right here at 0, 0. So it's saying if it went from 0, where's that on the line for your y value? Well, it looks like it's at negative 1 to me. So that's the answer they're looking for A. So negative 2 would be this point right here on the line because it went to the left 2. And then how high did we go up for my y value? It looks like we went all the way up to 1 for my y value. So that's the answer that it's looking for there. And then 3 would be right here. I'm dotting it out so you can see it. So where's that dot on the line? Well, it's right here. I'll make it a little thicker. So what's that y value there? Well, it looks like if we count down, we went down 1, 2, 3, 4. So that'd be negative 4 for that answer. So you just got to find the x value and look to see where that's crossing the y value at that point. So let's take a look at number 10. So this is stating for the first one, if I go to 1, let's see. If I go to 1, what's my y value? Well, if I go to 1, it looks like it could be right there. These are harder to tell. But I want to say it crosses right where I created that dot, okay? So it was right here, so where I created the dot. So how high is that? What's my y value? Well, it looks like it's at 2 to me. And if we go to 0, it looks like this curved line crosses at, for my y value, it doesn't look like it goes up either. It doesn't go left to right or up or down there, so it looks like it's at 0. Then if I go negative 2, it looks like it could be right where this dot is. So that dot that's on the left side looks like it's at negative 2 comma 4 for that y value. So it's giving you the x values for these in the parentheses, and you're just finding the y value on the actual graph. So then our last question, let's find the value of all these. So let's go to 1. So that's right here. We'll go all the way up to when we intersect it. So it looks like we intersect maybe we're at the very top there. I'll make it a little bit darker. So how high is that at the very top? Well, it looks like it's going to be at 1, 10. So that'd be my answer for A. If we go to -6 for my y or for my x value, how high? Where does it cross? Maybe like right there is where it crosses. So that looks like it could be at, what do you guys think? 5? Looks like 5 to me. And the last one, -3. Ooh, it looks like it's at the bottom here. So how low is that? Looks like it's at -4. So those are my 3 answers for